Workshop from Bangkok. Today we're going to do the steam ports in the cylinder block. So let's go and have a look. Okay. Hi, this is Al's Workshop from Bangkok. So there we have the steam ports, the feeding into the pistons. Those are the feeds in, those two slots. Those are the slots in the top of the pistons where the steam or the compressed air will exit into the top of the piston. So we're going to replicate those. First of all, we're just making sure the top is flat. It's just sat down on the in the vise. And then now we're just using the DTI to find the center of the first bore, because we've pressed the brass bushes inside and that could make them a little bit distorted. So it's always best to, once you've pressed the bushes in, is to skim them out to size. So leave a little bit for skimming. If you remember rightly, if we're going to press a bush in, you only want a interference fit of about 1/2 thousandth of an inch. And now we're just, with the boring bar, we're just skimming out to size. Left about 1mm to finish bore them both the piston bores out. So we'll complete one, and then using the DTI we'll just move over and finish the other one. So there we have, we've done a finishing cut now. So that is 20mm. It's quite accurate. Now we're going to mill, as you can see the drilled hole. That's the drilled hole that you feed the steam. Steam will come out of that. And then this is the slot which will be linked to the top of the piston. This is a 2mm slot. It's 4mm long and it's 8mm deep. So it's quite a small slot. So I'm currently just machining it, taking 1mm cuts, and I've zeroed the center of the job and I just move 1mm each side. It makes it very easy for calculating using a zero line in between. Okay, so we've completed that. So that's what that looks like. So that slot is 8mm deep. And as you can see, it's not broke through anything. So that's the steam or the compressed air will feed into that slot and out into the top of the piston. The round hole, the hole that you can see, that's where the steam or compressed air comes into the valve. Okay, now we're going to do the cutouts in the top of the piston. So there's 4 cutouts, one on each side, one on the top and the bottom. So these will feed the compressed air or steam, whichever medium you use. They will feed out of this and into the top of the piston, and that will be done on a timing mechanism with the valve. So the valve will move between both slots, and as the compressed air comes in through the center hole, the valve will feed it into whichever slot it currently is in line with. So it'll either go into the top or the bottom, depending on the timing. So we're currently cutting a 5mm slot, 4mm deep, before we put our drilled hole in. And the reason for that is there's a the guide comes up into a brass guide, comes up into the pistons 2mm. So the slot needs to be 4mm, and that will give us 2mm of that will give us 2mm of the to allow the steam or compressed air to enter the piston tube, and that's in relation to the 2mm slot, and that's why we need to go 4mm deep, as you will see later in the video. So we're going to do both sides, 5mm wide, 4mm deep, and we're going in 4.5 depth, going to the drawing. Once we've completed that, we then can drill through and break into the slot nearest to that side. We're just finishing off now, doing a final cut. We're using a 5mm 4-flute end mill on this job, just an high speed one. And so now we'll complete that. So as you can see, we'll just blow through the compressor and move to the drilling. Okay, so it asked for a 3.5 drilled hole. I've completed it 3.5. Knowing what I know now, I probably would have just done it in a 2mm or 3mm, because it's so close to the bore. It's only leaving 0.5 millimeter. There's only the wall thickness is only 0.5 millimeter. As you can see there, we broke through now, and the compressed air is blowing through. So that's good. And can you see the light there? Just to show you from another angle, it drilling through into that. Sorry about the camera. Can you see that it's light? And then when you put the drill in, the drill comes down. You can just see the drill coming down there. So, and there we go. I put a piece of wire through to show you. So the steam goes, or compressed air goes into the slot and then out into the top of the piston, and that is in both sides. So we've got that in each side, top and bottom, so that the compressed air or steam, I'll be using compressed air, that will enter the top and bottom of the piston. I'm quite happy with that. All of them have gone into this slot. The drilled hole is about 16mm deep, so when I was coming close to the 16mm mark, I took it nice and gently. I watched it break through into the slot. So that's all the steam ports for the thing all completed. The bore has been machined out to 20mm, so that's all ready, as you can see with the wire there, just to show the ball joined up. So all the four are in that position. I did have an accident with the 2mm slot drill. This is a slot drill with just 2 flutes. It was doing very well, and then all of a sudden it just snapped. And then I've tried a 4 flute end mill, and so I drilled first. But as you can see, where I believe that the shaft is far too big. I think probably 3mm would have been sufficient. Something just closer to the size, because it's just made it all the force. It's just breaking it like such a weak point where they both meet together. I think it'd be stronger if it was a smaller shaft where you could grip it, but never mind. It's just these things happen. And then we're gonna, as you can see, you've got your 2 brass guides there in the top, and they fit into the bottom of that, so they're 2mm thick. So when you place it on top of that, it slips into there. You've lost 2mm of your slotted hole, and as you can see, you can just see the small slots in the corner. There you go. So you've just got a 2mm one either side. That's fit on quite nicely, so I'm quite happy with that. So that's it for today. Thank you very much, and I'll see you next time.